Like to introduce or begin to introduce this idea of a unit circle. And what a unit circle allows us to do is help us to determine some trig functions of real numbers, not degrees or radians, but of real numbers. And in order to do that, we build a unit circle. Now, I skipped a few steps here, so if you're interested, you can go back and find some other resources to help you get to this point. But what a unit circle basically is, it's a circle as defined by x squared plus y squared equals 1 with a radius of 1 unit all the way around. So the radius is 1. That leads us to the idea where the angle swept by a particular, the measurement of an angle that's being swept out, well, that measurement in a unit circle also equals the distance of that arc length. So if I had some sweep of t, well, that's going to measure or equal the measurement of the arc length around as well. So that's useful for us as we can identify and build onto our functions some other correlations or some other equations. So if I have some point on the circle, wherever it's at, that's defined by x and y, what I know then is that the sine of this value, the sine of t, will equal the y value. Sine of t equals y. The cosine of this number, cosine of t, is going to equal the x value of that coordinate point. And then so forth as long as we go through the other four. The tangent of t is going to equal the ratio of my y coordinate over my x coordinate. And then the reciprocals will, of course, be the reciprocals of those. So anyway, that's just a little bit to introduce to you this idea of a unit circle, which is a circle of radius 1. And the usefulness of that is it allows us to help you determine some values for real numbers. So let me show you an example. So let's imagine I have a point identified as a point -1/2 and root 3 over 2. I drew a circle. I drew our unit circle as defined by x squared plus y squared equals 1. And you can also see that I had the point 1 and 0 marked as well as another indicator. I have a sweep measured out of t, which also equals the measure of the intercepted arc. And I have a point, the point that we identified is -1/2 and root 3 over 2. So all of that was based on knowing that I have the point listed as in our example. So from there, we can go ahead and determine what our 6 trigonometric functions are of this particular sweep of t. So if I wanted to know what the sine of t for this particular system that I have here, well, that equals my y coordinate, which is root 3 over 2. Again, we're looking at ways to find out the trigonometric functions of real numbers. Not degrees or radians as measured in this spot here, but real numbers. So the sine of t is root 3 over 2. The cosine of t, what do you think that one is? That's my x value, -1/2. My tangent of t is my y over my x. So root 3 over 2, complex fraction, -1 over 2, and that reduces down to negative root 3. My reciprocal functions, the cosecant of t is going to be a 2 over root 3. And then I need to rationalize the denominator there. So that's going to equal 2 root 3 over 3. The secant of t, likewise, is the reciprocal of -1/2, so this could be a -2. And the reciprocal of tangent is cotangent. Is going to equal -1 over root 3. Need to rationalize the denominator there as well, so that's going to equal -root 3 over 3. So there are the trig functions of real numbers based on the point that's described by the intercepted arc on a unit circle. So let's look at where I have a measure of t equaling pi halves. Have a unit circle. Yeah, I'm going to call it a circle even though it looks like it was squished and dropped off of a house a few times, but go with me. Let's pretend it's still a circle. It's a unit circle. I have a measure t, which is pi halves, which tells me the length that was the intersected arc is also pi halves, where I have a point at the end of that pi halves is at the point 0 and 1. So I have enough information then to figure out what is the value or the sign of these separate things. So what's the sign of pi halves? That equals my y value. My y value is a 1. The cosine of pi halves equals my x value at that point, which is 0. The tangent equals the ratio of my y over my x. Sorry, the tangent of, how can I turn that into a pi halves here? There we go. Equals 1 over 0. Undefined at that particular point. So the tangent of pi halves is undefined. The sine, so we have the cosecant of pi halves is the reciprocal of 1, which will tell me that it's 1. 1 over 1. The secant of pi halves is a reciprocal of this one. That's 1 over 0, which is undefined. And then the tangent, or sorry, the cotangent. The cotangent of pi halves, the reciprocal of the tangent, as noted over there as well. And the reciprocal of this is 0 over 1, which equals 0. So there I was able to find the trig values of a real number of pi over 2.